The other day we started talking about four quantum numbers. Now, if you remember, we said that first quantum number was n. And we said really it represented the energy level that that electron is in. The second quantum number was L. And we said L represented the sublevel that we were in. Now, if you remember, there were four sublevels that we identified: S, P, D, and F. And these values were 0, 1, a D was 2, and an F was 3. Our third quantum number, the third quantum number that we're going to talk about is going to be M. And M is going to represent our orbitals. And basically an orbital is just going to be the space occupied by one pair, and really a pair is two electrons. Okay, so an orbital is just going to be the space that is occupied by one pair of electrons. Now, if you go back and you think about the PowerPoint that I presented to you the other day, I said, well, an S was a sphere. And if you remember, we had a dumbbell in shape, or sorry, a sphere or a beach ball in shape, and then it got bigger and bigger and bigger and bigger. And basically each S, okay, an S is only going to have one orbital. Now, when we went to our P, now this is the one that I said was a dumbbell in shape. And again, if you remember that PowerPoint, how it showed you a dumbbell on the x-axis, and it showed you a dumbbell on the y-axis, and it showed you a dumbbell on the z-axis, well, that was actually showing you the three orbitals that existed for a P. A D, again, I said that one was the double dumbbell. Okay. Now again, there was that one that actually had a dumbbell and then it had that kind of donut going through the middle. But again, if you counted all of those, there ended up being 5 orbitals for a D. And then finally, we had the F. And again, that was the PowerPoint slide that showed you 7 different pictures. So basically, if you notice the pattern, it's going by odd numbers. So an S has 1 orbital, a P has 3 orbitals, a D has 5 orbitals, and an F is going to have 7 orbitals. So what we're saying is this, okay? If I was talking about the 1s, okay, and we're going to be talking about these orbitals and some orbital diagrams, but if I were drawing an S, 1s, I would draw 1 circle underneath. If I was talking about a 2p, I would draw 3 circles underneath. If we were talking about a D, so let's say that I had a 3D, I would go ahead and put 5 circles underneath. And each circle again is just going to represent an orbital. And again, the last one here is 4F. 1, 2, 3, 4, 5, 6, and 7. So I would draw 7 circles beneath. Now here's the thing that I also want to tell you about orbitals. Again, we said that things go from lowest energy to highest energy. Well, the thing is, this orbital right here isn't any less energy than this one here. As long as we are in the 4F, you are going to find out that they have equal amounts of energy. And if they have equal amounts of energy, they are said to be degenerate. Degenerate just means equal amounts of energy within oops, within a sublevels orbitals. So again, all of these right here, there are 5 orbitals within that 3D. Every single one of those is going to have the same amount of energy. Now, a 3D is higher than a 2p, so these orbitals here have more energy than those 2p. But within a sublevel, all 5 of those will have equal amounts of energy. Now, what are the values? The values for your orbitals is going to be negative L to positive L. And you might be saying, well, L's the letter. Again, L, remember, was your sublevels. And again, back up here where I said the value of S was 0. So what we're saying right here is the value of this right here is 0. Now, a P, the value of P was 1. And again, we're saying negative 1 to positive 1. So this one on the far left is going to be negative 1. The one on the far right is going to be a positive 1. And this one in the middle is going to be 0. Let's look at our D. The value of D is a 2. So we're going to have on the far left a negative 2. On the far right is a positive 2. And if we fill in between, negative 1, 0, and positive 1. And finally, our F. The value of F is 3. So again, we are going to go negative 3 to positive 3. And we're going to go ahead and fill in between. Negative 2, negative 1, 0, positive 1, positive 2. So, if I was talking about an electron right here, okay, so if we have an electron right there, N represented your energy level. That's this right here. So we would say N equals 3. L was your sublevel. The D represents the sublevel. The value of D up here was 2, so we would go ahead and put a 2 there. M represented the orbital. And if I drew my line in this orbital right here, again, that corresponds to that number right there, so my M would end up being a positive 1. Let's go ahead and look at our last or fourth quantum number. The fourth quantum number is S. And S is going to represent spin. Spin, again, is going to be which direction those electrons are going in an orbital. Now remember, an orbital was the space occupied by one pair of electrons. So the thing is, these electrons, they want to minimize repulsion. To minimize repulsion, those electrons are going to have to be going in opposite directions if there are 2 of them. There's going to be 2 types of spin. There's going to be clockwise spin, and there's going to be counter clockwise spin. One is going to be a positive 1/2, and the other is going to be a negative 1/2. Now, here's what I mean. You yourself are going to decide which way spin is. Okay? So if I'm talking about a 3p, and I go ahead and I put a line in here, okay? And again, if I'm talking about these lines, again, I can have lines there, there, but again, I'm going to make an X in there. So you need to decide, is that line going to be a positive 1/2 or a negative 1/2? Will this line here, will it be positive 1/2 or negative 1/2? That's what you are going to need to decide for yourself. There's 2 types of spin, clockwise or counterclockwise. One will be represented by a positive 1/2 value. The other is going to be represented by a negative 1/2 value. Well, let's get into some vocabulary before we actually put all four of these quantum numbers together. The first is going to be the Aufbau Principle. The Aufbau Principle just states that electrons begin to fill lowest energy to highest energy. Now really, we've already talked about that. Okay, that's when we did this 1s, 2s, 2p, 3s, 3p, 3d, and I'm going to put up here, etc. And remember, we drew our lines 1s, 2s, 2p, 3s. Now the 4s would be there. We would go 3p, 4s, and then we would go the 3d. So the Aufbau principle is electrons begin to fill those lower energy levels and sublevels before they begin to go to those higher energy levels and sublevels. The next one is going to be Hunds Rule. Hunds Rule is this. Electrons will fill each orbital in a sublevel before it begins to pair up. Okay. So electrons will fill each orbital in a sublevel before it begins to pair up. So for example, if I have a 5p, and again, we're going to come back up here, we're going to find the p, and a p has 3 orbitals in it. So again, I'm going to come back down here, I'm going to draw my 3 circles beneath. So what I'm saying is, if I had 4 electrons that needed to be placed, those electrons will go 1, 2, 3. So I filled each orbital first. Now I put my 4th electron back in. So electrons will fill each orbital in a sublevel before it begins to pair up. And the last vocabulary is the Pauli exclusion principle. And all this states is no 2 electrons will have the same 4 quantum numbers. If it has the same 4 quantum numbers, it's the exact same electron. We can have 1 quantum number be the same, we can have 2 be the same, we can have 3 be the same, but you cannot have all 4 be the same, because again, if it is the same 4 quantum numbers, it is exactly the same electron. What we want to do now is we want to talk about filling orbital diagrams. And orbital diagrams is going to be placing all of these quantum numbers together. The example problem we're going to do is 10. And 10 has 50 electrons. So here's what we're going to do. I'm going to go ahead and put this mnemonic up, 2s, 2p, just so we know exactly how far we need to go. Hopefully this will be far, hopefully this will be far enough for us. So here's what we're going to do. So 1s. I'm going to draw my circle. There's one electron, there's two electrons. So there's electrons 1 and 2. Now you don't have to put the numbers. I'm just doing this to show you exactly where we're at. Okay, come over here, 2s. Again, an s is only going to have one circle underneath. So 3 and 4. Okay, after 2s is going to come 2p. A p, we said, had 3 circles. So here's 5, 6, and 7. Now notice what I did. I put them in each orbital first. That's Hunds Rule. And then I come back. So 5, 6, 7, 8, 9, 10. So we went 5, 6, and 7. We went 8, 9, and 10. After 2p comes 3s. And s is going to again hold 2 electrons or 1 circle. We go 3p. 1, 2, 3. So here's 13, 14, 15. 13, 14, and 15. Here's 16, 17, 18. 16, 17, and 18. After 3p comes 4s. There's numbers 19 and 20. After 4s, okay, 4s comes 3d. Now a d, if we come back up here, a d has, there it is over here, a d has 5 circles, okay, or has 5 orbitals. So 1, 2, 3, 4, and 5. So we're at 20, 21, 22, 23, 24, 25. So 21, 22, 23, 24, and 25. We're halfway done. 26, 27, 28, 29, 30. So 26, 27, 28, 29, and 30. After 3D came 4P. P has 3 circles. So 31, 32, 33, 34, 35, 36. So 31, 32, 33, 34, 35, and 36. After 4P was 5S, 37, 38. After 5S comes 4D. Again, a D, 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. Okay, so 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So 44, 45, 46, 47, and 48. We've got 2 left to go. So after 4D comes 5P. P, 1, 2, 3 of them. With there being 3 of them, we're going to go 49 and 50. We're done. 49 and 50. This is an orbital diagram. An orbital diagram represents the energy levels, the sublevels, and each of the orbitals within the electrons being placed in each orbital according to their spin. Now, here's what I want to do. I want to go ahead and just pick some random numbers. I'm going to go ahead and pick number 23, and I'm going to go ahead and pick number 45. Okay, electron number 23 and electron number 45. So what I'm going to do is I'm going to describe electrons. I said 23, 45, and let's go ahead and go one more. Let's go ahead and go 49. Using the 4 quantum numbers. Okay, I'm going to change colors here. So, we've got electron 23, 45, and 49. And here's what I'm going to want. I'm going to want you to describe N, L, M, and S for those. Now let's go ahead and look here. Okay, 21, 22, 23. Now if you remember, I made my first slash always like that. Okay, so there's 23. Okay, let's find 45. So now it went 39, 40, 41, 42, 43, 44. Okay, there's number 45. And then the last one is number 49. And number 49's right there. Okay, so I just kind of exaggerated them. N represents your energy level. And I said, again, that's going to be that number, and that number. Basically, we're saying it's the number in front of the letter. So for 23, the energy level was 3. For number 45, the energy level was 4. And for electron number 49, it is 5. Now, L. L represents your sublevel. And that's this right here. These letters. Okay. Now again, off to the side, I'm going to write them. S, P, D, and F. S we said was 0. P we said was 1. D we said was 2. And F we said was 3. And again, those notes can be found in the PowerPoint that I gave you over the weekend to look at. So let's go ahead and look at number 23. 23, it said 3D. D, right here. It's a value of a 2. 45, okay? 4D. Again, it is a D, so I'm going to go ahead and put a 2 in there. And number 49 is over here in the 5P. The value of a P was 1. Okay, now we're going to look at M. M is the orbital, and that's what we started talking about today. And again, if you remember, it is negative L to positive L. Okay, and L was this number right here, the 2, and the 1. So basically we're saying here, negative 2, negative 1, 0, positive 1, positive 2. Now look where my red line is. It corresponds to the orbital that has a 0 value. Okay, over here, negative 2, negative 1, 0, positive 1, and positive 2. Again, look where my red line's at. This one's going to correspond to the negative 1. And finally, 49, okay, negative 1. And here's the reason why. Again, look back up here. The value of a P was a 1, so we're going to go negative 1, 0, and positive 1. And look where my red line is. It is in the 1, or the orbital, that has a negative 1 value. Now, The last one is spin. Okay, again, I'm going by how I do it. Okay, now again, when you think of my circles, when I draw them, I always made my slash there. Okay, so that was my first slash, and then I came back and that was my second slash. So basically what I say is my first slash is a positive 1/2, and I always say my second slash is a negative 1/2. Now that's up to you on how you want to remember them. But if I go ahead and I look at my number 23, and I look at that and I say, well, that's my first slash, so I would call that a positive 1/2. 45, okay, look, 45 is opposite in direction as my number 23. Because it's opposite in direction, I would have to say, well, that one's going to be a negative 1/2. And the last one is number 49. Number 49, if you look, that slash matches the one in 23, and in 23 I said it was a positive 1/2, so I have to make sure that that one is a positive 1/2 also. The last thing that I want to talk about is I want to talk about valence electrons. Valence electrons are your highest let me get that fixed. Highest energy level. That's going to be a key word there. Energy level. Highest energy level electrons. Now, when I come back up here, I've got a 1, a 2, a 2, a 3, a 3, a 4, a 3, a 4, a 5, a 4, and a 5. So what we're saying is 410, my fifth energy level, was my highest energy level. So what I have to do is I have to find all of the electrons in the fifth energy level. So what we're saying is I've got 2 electrons that are there, and I've got 2 electrons that are there. I'm not going to worry about this 4D right here, because again, that's in the fourth energy level. We're looking for the highest energy level. So what we're saying is 10 has 4 valence electrons. It has 4 valence electrons. And what they were is that they were in the 5s2 and then the 5p2. Okay? So we had 2 that were there, and we had 2 electrons that were there. And the final thing that we're going to do is we're going to look at electron dot diagrams. Electron dot diagrams were just a shorthand representation of an element and its valence electrons. Now, electron dot diagrams is going to be a little bit different than I taught you in physical science. If you remember in physical science, we again said put the element symbol. And then I said, well, again, don't write this down. Okay, this is going to be incorrect. But if tin has 4 valence electrons, I would have said start on this right side and then work your way around the symbol. Well, about the only thing that was true about that was you start on the right side. So I'm going to go ahead and come back here. And what I'm going to do is draw up the template. All of your S electrons are going to go on the right side of the symbol. Your P -1 electrons are going to go on top. Your P negative, my bad, I get rid of that. Your P0 electrons are going to go on the left side, and your P +1 electrons are going to go on the bottom. And you might be asking yourself, what do you mean by P -1, P0, and P +1? Remember how we numbered our orbitals. This was the -1 orbital. This was the 0 orbital. This was the +1 orbital. So if I were to do this for tin, the symbol Sn. On the right side goes my S electrons, right here. And when I look there, that circle has 2 lines in it, or it has an X. So I'm going to go ahead and put my 2 dots right there. Those are going to represent the electrons that are in the S. When I go to the -1, there's only 1 line in it, so there's only 1 electron. P -1 goes on top. I come over here to the right. There are 0, or my 0 orbital has 1 line in it. So it too also has 1 dot on the left side. And when I look at my +1 orbital, there's no lines in it. There's no electrons. So again, here are the 4 valence electrons for tin. Now you might be asking yourself, well, Mr. Solomon, this only has S and P in it. What if I get to a D? Well, let's go ahead and come back up here to this. Notice, here's my first D, 3D. Before I got to that 3D, notice what happened. 4S. I got to a higher energy level. You will only have to worry about S's and P's for your highest energy level in your dot diagrams. S, P -1, P0, and P +1.